Okay, let's take a look at another word problem, or a word problem. So an open top rectangular box. I'm just going to start by sketching that open top rectangular box. Two rectangles, connect all the corners, and I'm going to shade the top because it's open. By cutting equal integer lengths from each corner of a 12 centimeter by 15 centimeter piece of cardboard. So as you can see in the notes, I've drawn two rectangulars, but I'm just going to draw one this time. So if we take a shape and call it 12 by 15, and I cut equal corners from each corner, well, what is the length of the corners that I'm going to cut off? Well, I know they're all the same length, first of all, and when I don't know something in math, I make it x, so they're all x, 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 and x. Therefore, I'm going to be cutting those corners off, and I'm going to be folding them up, and I'm going to get this base here. Now, what's the length of that base? Well, I know that if I cut off an x and an x from a 15, my length is 15 minus 2x from here to here. And if I cut off an x and an x from a 12, I know that it's 12 minus 2x from, here. Exactly where I cut them off. So transferring that information, I have one side which is 12 minus 2x, another which is 15 minus 2x. And if you can imagine folding up all the corners, I suggest actually doing it and then asking yourself what the height is. But the height is x, because if we cut a corner of x and fold it up, that's what the height is. So we have a formula for volume. V equals length times width times height. I'm going to go capital L. So now, substituting into the formula, we get V equals, so length times width times height, I'm going to do it in this order. 15 minus 2x, 12 minus 2x, and then x, the height. Now, I'm going to read the rest of the word problem. So find the length of the squares that must be cut from each corner. So the box is a volume equal to 162. So I can simply take V and I can substitute 162. And then the right-hand side stays as it is. And sometimes I'm going to say dot, dot, dot. Feel free to rewrite it. And now I'm going to FOIL it all out. So I'm going to multiply this all out. And then combine it with the x after. So I'm going to let you do that for fun at home, but it FOILs out to be 180x minus 54x squared plus 4x cubed. Now I'm going to get it equal to 0, so 0 equals, and I'm going to rearrange the order of the terms so I have the highest degree first. 4x cubed minus 54x squared minus 180x. And if I subtract 162 from both sides, it shows up on the right-hand side as minus. So the first thing I notice, I can divide everything by 2. And again, remember, I'm not going to show those steps. If I divide the left-hand side, 0 divided by 2 is 0. And I get 2x cubed minus 27x squared minus 90x minus 81. So then I'm going to list my potential factors of the negative 81 to be plus and minus 1, 3, 9, and like, sure, keep going, but like it's not going to be something gigantic. So like if I have a rectangle from above with side lengths of 15 and 12, and I want to cut two parts off, well, I can't cut a 9 off of both sides. So I only have to worry about plus and minus 1 and plus and minus 3. So feel free to continue looking into the notes, solved by inspection. I'm just going to do the one that worked. f of 3, substituting 3 into the equation above, as seen in the notes, gets 0. When we do synthetic division with the 3 and we do the process, we get 0. Now, in the notes, feel free to continue to read. I continued to factor it. I got 9. I rejected it. It was too big. I got 1.5. I rejected it because the question asked for integers. So I know that f of 3 is my only x-intercept. Therefore, x minus 3 is a factor, and x is equal to 3. If I substitute back into the original equation, v equals, well, 12 minus 2x, 15 minus 2x, and x. And if I take 3 and I put it in for x, well, that means that I have a length of 6 and a width of 9 and a height of 3, and that confirms a volume of 162, let's use some units, centimeters cubed. But the answer to the question is in blue down below. X equals 3 is the exact x value to cut. So when we make an open top box, we get the exact volume of 162. Feel free to take a look at the graph in the notes. The last part of the word problem says, and find the length to cut for the maximum volume. Well, we're going to type the volume equation, forgetting that V was 160 as seen in the notes, the exact volume equation in the notes. And then we're going to graph it, and we're going to find the point on the graph using second calc maximum and find out that the x value is 2.2 to maximize the volume of 177.2, bigger than 162. Why would we want to do that? Well, we may want to maximize the volume for a certain amount to cut off if we want to have the biggest container with the given material. We'll work on that later in calculus. That's the end of chapter 3.